Welcome to Homework Lib.
Hi, so in this case, we are not told how much energy is actually provided to our system, but we know that we have 100 grams of ice, right? So, the other information that we have is my initial temperature that is going to be equal to minus 10 degrees Celsius. Now, how do I know what is going to be the final temperature? Well, if I provide a certain amount of heat, this is the value that is missing in your problem, that is going to be given in kilojoules, the transformation that that is going to produce is related to, first of all, consider that we have a diagram that shows us temperature versus heat, and initially we have minus 10 degrees Celsius. The other point that it's going to be interesting is going to be 0 degrees Celsius, and way up top over here 100 degrees Celsius. In that case, it is probable that the quantity that is given to you is not going to be enough to move the temperature of the water all the way to the boiling point, but let's see what is going to happen in all of the cases. So in the first portion, the amount of heat, it is going to increase the temperature of the ice. Then we're going to have a portion where it doesn't matter that I am still adding heat, the temperature is going to be kept constant. That is because that energy is being spent on the melting of the ice. Next up, I'm going to increase my temperature again all the way until I get to my boiling point. Then I have my associated evaporation, and then I can increase temperature again. So just as a reminder, in this first region I'm going to have solid. Over here I'm going to have a solid and liquid. In this region only liquid. Over here liquid and gas in equilibrium, and over here we're going to have only the gas portion. So how do I calculate the amount of heat that I have added? Well, that is going to be mass times heat capacity of ice, first of all, delta T for ice, plus we're going to have the amount of mass of ice that I'm still going to have, times delta H of melting, plus M heat capacity of water times delta T for water. So, in most of the cases that you're going to deal with here, the amount of heat that they are going to provide you is enough to melt everything and rise the temperature a little bit. So what you need to do is, given the amount of heat that is provided, you're going to start subtracting these quantities over here. First of all, delta T for ice, if you were able to completely melt it, it would be T final minus T initial, in this case, 0 degrees Celsius minus 10 degrees Celsius, right? So delta T for ice, it is going to be equal to 10 degrees Celsius. You just need to substitute the value for the heat capacity of ice. Next up, we're going to have the process corresponding to the melting. And over here, the enthalpy for melting, you need to provide it in either joules or kilojoules per gram. And in the case that you have it in kilojoules per mole, so if delta H is in kilojoules per mole, then the formula changes a little bit, and instead of having M, you're going to have N as in the amount of mole. How do I get the amount of moles? Simply N, it is going to be equal to 100 grams of ice, that is the same as grams of water, divided by the molecular weight of water, that is 18 grams per mole. Okay. And finally, you can add the final process that would be increasing the temperature for the water that you have in your system. So, depending on how much heat is provided to you, you're going to be able to either melt all of the ice, to just melt a portion of the ice, or to just increase the temperature of the ice. In the case that that quantity is larger than that, then potentially you may have two other factors over here. That would be, let me erase everything here. Here, just a clarification depending on what is the value that is provided to you. The other potential factors would be N times delta H of vaporization, or depending if they give you the value directly in kilojoules per mole or in kilojoules per gram, you can use either of them. And finally, plus mass times C of water but gas, right? And delta T of water as a gas. Okay. And that would be all. Of course, this problem you need to provide the value for the heat in order to get the full solution, but this is the outline or on how to solve it.